Alright, we're looking at trig functions of any angle today. We've dealt before with trig functions using the unit circle. In upcoming videos, we're going to talk about how to use right triangle trig and SOHCAHTOA. But this one, we're going to be using reference angles now to find a trig function at any given angle. And the first thing you're going to want to do is jot down this chart right here. We have our four quadrants, quadrants 1, 2, 3, and 4. And basically, we need to talk about some of the things within these quadrants. And the main thing is what happens with sine, cosine, and tangent. So in quadrant 1, we're going to do this with all of them. We have sine, cosine, and tangent that we're going to have to talk about. In quadrant 1, we have positive x values because we were going off to the right. And then we're going to have also positive y values because we're going up. So because of that, the y values are sine, they are positive. Cosine is x, those are also positive. Tangent is just those two values divided, so a positive divided by positive becomes a positive. Well, that's good, that's very not interesting. Everything's positive. Well, let's take a look. It's going to change here in these other quadrants. In quadrant 2, we're still going up above our y-axis, so sine is still positive. Cosine, though, is negative because the x values have moved to the left from the origin. Tangent, then, is also going to be negative because positive divided by negative gives you negative. In quadrant 3, both sine and cosine are going to be negative because I'm going down and left. Tangent, however, now becomes positive because we are dividing a negative divided by a negative. And then this last one with sine, cosine, and tangent in quadrant 4, sines are negative because we're down below the axis. Cosine, the x values are positive, and that makes tangent become a negative. So the short, easy way to deal with this is in quadrant 1, they are all positive. In quadrant 2, only sine is positive. Quadrant 3, just tangent. Quadrant 4, just cosine. The moniker we use is all students take calculus. So mnemonic device to help you remember which quadrant gives which trig functions being positive values. And we're going to use that here in these examples. Before we get to this example, the other thing I want to remind you of is the trig table that we are going to be dealing with. So this is a reminder of how to make it. You have sine, cosine, and tangent. And when we make our table here, our values across the top are 0, pi over 6, pi over 4, pi over 3, pi over 2. If we want to use degrees, that's 0 degrees, 30, 45, 60, and 90. And the values that we have for those trig functions, sine of 0 is 0, and then we use our pattern, square root of 1 over 2, 2 over 2, 3 over 2, square root of 4 over 2. This is just backwards. And then we divide them. There's your table. You should have that memorized, but we'll look at that here in a moment as we go to solve these problems. So, find all 6 trig values for this angle. So the first thing you want to do is figure out what your quadrant is and what your reference angle is. Well, your quadrant for this problem is going to be quadrant number 2 because we're between 90 and 180 degrees. Your reference angle in quadrant 2 is how much to get to the x-axis. So that's going to be 30 more degrees to get you to 180. That's the quickest way to get there. So now I can use my trig table, and I'm going to read off what from the reference angle here of 30. So when you look at that trig table, looking at 30 degrees, the sine value is 1/2. The cosine value is square root of 3 over 2. When you divided them, you had the square root of 3 over 3. The other 3 are just the reciprocals of those. 2 over the square root of 3, which will reduce to be 3 over 3. And this guy will reduce to be just square root of 3 when you flip that. So you've done nothing different. The issue is with this right here, with what quadrant we are in. In quadrant 2, again, remember, we have all students take calculus. In quadrant 2, sine should be the only thing that's positive. So that means cosine and tangent should both be negative. If those are negative, each of their reciprocals also should be negative. So sine should be the only positive value there, and cosecant should also then stay positive as well because they are just the reciprocals of each other. Let's look at another one. 315 degrees is 45 degrees as the reference angle, not as the quadrant. See if I can get that. There we go. And so the quadrant we're going to have here is quadrant 4. 315 between 270 and 360. So you can also look at it this way. In quadrant 4, all students take calculus. That means that cosine should be the only thing that's positive. So I might say even right now, hey, look, those values are all negative. Well, cool. Now I can just read off the trig table, and 45 degrees is what I'm using because that's my reference angle. So sine and cosine are both the square root of 2 over 2. Let's try that again. Maybe not. Square root of 2 over 2. And when you divide them, the tangent became 1. When you flip all of those for the reciprocal, those are the values that you would end up getting. And again, you already have the negatives now because of what quadrant you're in. All right, and it works the exact same way for radian mode. It's just a matter of figuring out what quadrant you're in. So 4 pi over 3, draw it again. All students take calculus. Quadrant for 4 pi over 3 is going to be in quadrant 3 because you're between pi and 3 pi over 2. 11 pi over 6, we'll just do that right now. That's in quadrant 4. To figure out your reference angles, if you're in quadrant 3, you're going back to pi. So how much to get back to pi would be a pi over 3. For 11 pi over 6, you need to be getting up to 2 pi because you're right now in quadrant 4. You need to be going up the rest of the way. So that's going to be a value of pi over 6. Figure out your sines first if you would like, or you can do it at the end. Doesn't matter. Quadrant 3, tangent is the only thing that's positive, so everything else should be negative. And what we should have here as well, we haven't really done it yet. In the last problem, it said like sine of 315 degrees. You can write it out that same way. You can call it sine of 4 pi over 3. Or because they're calling that value theta, we can say all of these are just sine and cosine and tangent of theta for all of them. Same with this problem down here, dealing with what we're calling our angle. A little bit shorthand, that might help. But as we continue, now we can just read off of what the chart is. At pi over 3, we have sine is root 3 over 2, cosine is 1/2. When you divided them, it was root 3, and their tangent's the only thing positive. When you flipped those values, that became 2, this became root 3 over 3, and cosecant at the top was 2 square roots of 3 over 3. Okay, finish this last guy off. Quadrant 4, cosine's the only thing that's positive, so the rest are negative. Pi over 6 is the angle we're using in the chart that we should have memorized by now. And basically it's just the flip of what we had on this last problem, where now sine is 1/2, cosine is root 3 over 2, so tangent when you divided them was root 3 over 3. Flip them all around, and now the secant has the 2 root 3 over 3, cosecant becomes your -2. So the sines are the big important part. Knowing that chart is also important as well, and the biggest is up here, all students take calculus. There you have it. Reference angles to find trig functions.